Hello students. So this is the continuation of our previous session, star to delta conversion. Okay. So this is the problem of 2018 and the question is making use of star to delta transformation. Determine the resistance between terminals A and B as shown in figure. Okay. So we are going to use star to delta transformation to convert this star into delta and find out the equivalent resistance. Okay, so let us start on with, so either you can convert the inner star to delta or outer delta to star. So I am converting here delta to star. That means, so first let me draw this outer delta. Okay, so this is the delta. Okay, so here it is A, it is B, right? So let us point this also as C and D. So here it is A, here it is C, here it is D. So the value of resistor here is R, here also R, here also R. So let us convert this into star, right? So I'm using another ink so that you can get a different. So this is how I am representing my star connected network. Okay, so as it is connected to point A, let it be RA. As it is connected to point C, let it be RC. As it is connected to point D, let it be RT. Okay, so converting a delta to star. So how to convert a delta to star? So you at a particular point, that is for RA, A is the point. So at this point, what are the two resistors connected? That is R and R, right? So RA is equals to R into R by R plus R plus R, that is product of the resistors connected to that point divided by summation of all individual resistors. So it will be R square by 3R, which is equal to R by 3. So this is the value of RA. Similarly, RC will also be R by 3 because the same value of resistors are connected, and RD is also same R by 3 because they are connected with the same value, right? So these are in ohms. And one more point here you need to note down is, whenever same value of resistors are connected in delta or star, to convert that from one form to another, we can directly use this. Okay, so when all resistors are of same value, okay, when all resistors are of same value, then to convert delta to star, delta is delta to star. So here you can see that, like, these are 5 letters, these are 4 letters, so it is converting from 5 to 4, that is there is a decrement. So you need to divide it by 3. The value of R should be divided by 3. Similarly, to convert star to delta, that is star to delta, so there is an increment in the letter, so you need to multiply it with 3, so it will be 3R. Okay, so here we have converted delta to star, so we have to, what we have to do, we have to divide it by 3, so that is what we have obtained. So now we have to replace this star formation to the main circuit. So let me draw this circuit here once again. I am drawing the inner circuit of star. Okay, inner circuit of star. This is point A, this is point B, this is C, this is D, right? So again here the delta converted star I am drawing. Okay, this is point A, this is point C, and this is point D. So here we are going to get an extra point, okay, of star. So we have to just connect this to this. So C is connected to point C, again D is connected to point D, and A is connected to point A and B is connected to point. Okay, so how you can look at this? This is 2r, 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 r by 3, r by 3 and r by 3. So if you see here, this r by 3 is in series with 2r. Again this r by 3 is in series with 2r, right? That combination is in parallel. So I am going to draw this circuit in the next slide again like this. So this is point A. Okay, this is also point A. Okay, so in between there is a resistor. This is point like this. Okay. This is point B. This is point A as mentioned. Okay, so this is R, this is R, this is R by 3, R by 3. Here it is 2R, here it is also 2R, here it is R by 3. Okay, so the points of point D is connected here, point C is connected here. So R by 3 and 2R are in series. Next R by 3 and 2R are in series. This combination is in parallel and that is in series with R by 3. Again that combination is in parallel with 2R. So we are going to just simplify this series parallel connection. So it is R by 3. Here it is 2R. So these 2 points are connected to point A. Okay. Now here we are going to get one resistor value whose value is nothing but R by 3 plus 2R in parallel with R by 3 plus 2R. Okay, R by 3 plus 2R in parallel with R by 3 plus 2R. Okay, so this is the value of this resistor. So here after conversion of this you will be getting, as these two are in parallel, so you can directly make it as half. Like you can see here, it is nothing but 7R, 3 to the 6 plus 1, 7R by 3 in parallel with 7R by 3. So when same resistors are connected in parallel, what we can get? When same resistors are connected in parallel, then what is R equivalent? R equivalent is nothing but R square by 2R, that is R by 2. Right, here also same resistors are connected in parallel. So what is that value? 7R by 3 into 2. So that is nothing but 7R by 6. Okay, so 7R by 6 is in series with R by 3. Okay, so now the resistance value is like this. This is A, this is B, this is 2R, this is R by 3 and this is 7R by 6. Okay, so after calculation you'll be getting it as RAB is nothing but 0.85 R ohms. Okay, so 7R by 3 plus R. 7R by 6 plus R by 3. What is this value? This value is nothing but this is 18. 7 3s are 21R plus 6R. It is nothing but 27R by 18. Okay, so it is nothing but 9 3s are 9 2s. That is 1.5R. Okay, so this is the combination of 1.5R. So 1.5R is in parallel with 2R. Okay, so 1.5R is in parallel with 2R. This is points AB. So now what is that? 1.5R into 2R divided by 1.5R plus 2R. It is nothing but 0.85 R ohms. So this is what the equivalent resistance of the given star to delta combination. So first you need to identify which point you need to convert, either to star or to delta. So after conversion, you need to exactly place the points and you need to get the answer. Then only you will be getting the correct circuit in series parallel combination. Otherwise it will be difficult. Okay, so moving on to the next question. So this is the question of 2020, that is recent, and this is for 15 marks. Okay, so but the circuit is very simple, you need to just understand what to convert. Okay, so if you see here, the circuit consists of all 3 ohms except 2 resistors which are of 6 ohm. So if you observe this 6 ohm and this 6 ohm is in parallel. This 6 ohm and this 6 ohm is in parallel. So parallel combination of 6 ohm. Parallel combination of 6 ohm. So 6 into 6 by 6 plus 6. It is nothing but 36. 36 by 12. It is nothing but 3, right? So here this combination is 3 ohm. That means the circuit is like this, which has been mentioned here. Okay, this is B. 3 ohm, 3 ohm, 3 ohm, 3 ohm, 3 ohm, right? So you can see that either you can convert the upper delta, like upper, these 3 resistors are forming delta, like let us mention here as PQR and S. Okay, so PRS is forming one delta, RSQ is forming another delta. So you can either convert any of the deltas and you can solve it. Okay, so I am converting RSQ delta. Okay, so RSQ. Okay, this is point R, this is point S, and this is point Q. So here 3 ohm, here 3 ohm, here 3 ohm. Okay, that is nothing but it is like this. 3 ohm, 3 ohm, 3 ohm. Okay, so this is suppose R, S, and Q. Okay, so I am converting star into delta. So sorry, delta into star. So I am drawing a star circuit. Okay, I am drawing a star circuit. So this is Q, so it is RQ. This is R, so it is RR. This is S, so it is RS. Okay, now what is RQ? RQ is nothing but the point. At point Q there are 2 resistors connected. 3 into 3 by 3 plus 3 plus 3. So it is nothing but 9 by 9. So it is 1 ohm. Similarly, RR equal to 1 ohm and RS equal to 1 ohm. So if you have any confusion with the formulas of star to delta, you can just simply remember that logic when you are converting from star to delta, as there are number of letters are higher for the conversion, so you need to multiply it with 3. If it is from delta to star, so there is a decrement in the letter, so you should divide by 3. So I am converting here delta to star. So what I need to do? I need to divide it by 3. So 3 divided by 3 is nothing but 1. Okay, so this is how you can cross verify whether you are doing it correctly or not. Okay, so now replace the star in the original circuit. So this is how the circuit is connected. Okay, so this is 3 ohm, this is 1 ohm, this is 3 ohm, this is 1 ohm, and this is 1 ohm. So here you can observe that 3 and 1 are in series, 3 and 1 are in series, that combination is in parallel, and that combination is in series with 1 ohm. So let us solve that. Okay. I'm just replacing the two resistors in one resistor. Okay, so this is P and this is Q. Okay, so now it is 4 ohm, here also 4 ohm, and here 1 ohm. Okay, so what is that? Same resistors are connected in parallel, so we have to divide it by 2. So now P, Q, 2 ohm and 1 ohm. So the equivalent resistance between P and Q terminal is nothing but 3 ohms. So this is how you are going to solve the circuit. First convert star to delta and or delta to star, depending on the question and the points you are clear about. Okay, so then after conversion, replace that in the original circuit correctly and you can solve the series parallel combination. Okay, right, thank you.